Factoring simple trinomials. The first question would be, what is considered a simple trinomial? If we consider a trinomial in standard form, we would talk about ax squared plus bx plus c, and a simple trinomial would always have the a value equal to 1. So just for example, x squared plus 12x plus 32. Before we begin the factoring, let's remind ourselves how we expand and simplify two binomials. So remember, this is essentially the distributive law 2 times. We would do x times x times -6. So the first term times each of the terms in the other factor, and then the 5 times the x and the 5 times the -6. So essentially, we would end up with x squared minus 6x plus 5x minus 30. And then usually, quite often, these middle terms will collect and we get x squared minus x, or 1x, minus 30. So what we are going to do, as we've talked about before, is that factoring is the opposite of expand and simplify. So we're going to go from the trinomial, from the basic or simple trinomial, to essentially 2 brackets most of the time. Sometimes we'll have something extra as well, but for these most basic ones, we're looking for 2 brackets that have binomial inside each one, so 2 binomials that will end up equaling a trinomial. Let's try that. So we are going to factor x squared minus x minus 30, which is what we were just talking about. So right away we notice, what you want to notice is that there is no common factor, because we've talked about common factoring before. There is nothing common among all 3 terms. So then the next thing you want to notice is that the a value is equal to 1 here. So that means we have a simple trinomial, and that means we can do some more basic things when we do our trinomials. So we know automatically then that we want 2 binomials that when we apply our distributive law twice, or sometimes people call it FOIL, that we would end up with x squared minus x minus 30. So we get x and x. That's always going to be our first thing, so what our first term in each bracket. So whatever that first term is in the trinomial, you just want to take the square root of it, basically. So in this case, it's x squared, so the square root of x squared would be x and x. And then this is where it gets tricky. We got to figure out what those last 2 terms would be. So our last 2 terms, so the term at the end of each bracket, or the end of each binomial in the bracket, would the 2 numbers together have to multiply to give me -30, and they have to add together to give me -1. Remember, there's a 1 there. So to give me a -1. So the easiest way to do this is try to start with the things that are multiplied. So all the ways of getting 30 is 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 works, 5 times 6, and then 6 is the next one. So we've covered all of them. So those are all the different combinations or factors of 30. And remember, to get -30, we need 1 to be positive and 1 to be negative. So off to the side, we keep that in our mind. 1 has to be positive, 1 has to be negative. So now what we want to do is focus on adding those combinations. So if I added 1 and 30, if I added and they were both positive, be 31. If they were both negative, be -31. So none of that works, because we want to add to get -1. And if one's positive, one negative, which we know has to be the case, then that's not going to work either. You would either get, if -1 was the negative and positive 30, we would get positive 29, or if we reversed it and that was the positive and that was the negative, we'd get -39. So that one doesn't work at all. And we go down using the same logic for each of those. So if one is positive of the 2 and one is negative, so the 2 and the 15, you're still going to get like -13 or 13. So that's not going to work. 3 and 10, that's not going to work. 5 and 6 has a difference of 1. So if I was adding these now, not multiplying them, but adding them, I would need the 6 to be negative and the 5 to be positive, so that when I added those together, I'd get that -1 in the original trinomial. So that means in my bracket, I'm going to put a -6 and a +5. Now, I always get the question, does it matter where the -6 and the +5 go? And it doesn't. You could have totally written it like x +5 and x -6. It doesn't really make any difference. Either one of those is fine, because when you apply your distributive law and multiply it out, expand and simplify, you will still end up with that no matter which form you have it. So that's the essential thing, is to find two numbers that multiply to give you the last term, add to give you the middle term, and then your first number in each of your binomial brackets, so this number here, or this letter, sometimes it's a number, sometimes it's a letter, is just going to be the square root of that first term. Now it's your turn to try some. Here are 3 questions for you to practice. Give them a try. Notice that I added if possible. So this says factor the 3 trinomials given if possible. There is one in here that is not possible, meaning you cannot find 2 numbers that multiply to the last term and add to the middle term. But take a look at them, see if you can figure it out, and then you can push play again. Push pause and then push play again to see if you got them right. As you think through these, just to give you an idea of what to do, you are always going to put, if for these simple trinomials, the square root of whatever your first term is as the first term in each bracket. So we've got x and x in that case. And in the second case there, we're going to have a and a. And then for the last one there, we're going to have x and x as well. So that's the first thing to recognize. Also notice that you don't have any common factor. That's really the first thing you should notice. There's no common factor in the trinomials. So there's nothing that you could pull out ahead of time before you do this process. Then you're going to look for something that multiplies to give you the last term and adds to give you the middle term. So start with all the things that multiply to -28 for the first one, and I put them down below. 1 times 28, 2 times 14, 4 times 7. And then what you want to do is find 2 terms that will add to the -11. And remember, it has to multiply to -28. So one of the terms has to be positive and one of them has to be negative in order to get that -28 there. So that's something to keep in mind. So 1 and 28, if one was positive and one was negative, it's never going to get to 11. 2 and 14, again, if one was positive and one was negative, you'd work somewhere around 12 or something like that. That's not going to work. The 4 and the 7, right away you go, oh, that's 11, but remember that one has to be positive and one has to be negative. In order for that to work, you'd have to make them both negatives. -4 and -7 would give you -11 when you add, but then when you multiply 2 negatives, you would get a positive. So this one actually is unfactorable. We call it unfactorable. It is impossible to actually factor this with our nice numbers. And there is ways to find some roots and stuff with this, but when you're just factoring, this one is unfactorable. When you look at the second one, again, you're looking for 2 numbers that multiply to -15 and add to -2. So 1 and 15, 3 and 5. Again, we have a negative when we're multiplying, so we need a positive and a negative in the 2 numbers that we choose. If we use a positive 1 and a -15 or vice versa, that's not going to give us -2, but the 3 and the 5 would. So we need to figure out which one's going to be positive, which one's going to be negative. We know that when we put them together, it has to equal -2. So it's going to have to be a -5 and a +3. So then up in your brackets, you're going to put that +3, -5 in there. Or again, you could write it the other way. You could do a -5, a +3. It doesn't matter which order you put the brackets. The last one, you have to multiply to 9, add to +10. 1 and 9, 3 and 3 are our only options. In order to add to +10, you would have to have a positive and a positive, and also to get a positive at the end, you'd have to have a positive and a positive, or a negative and a negative. But in order for that middle term to be positive, we have to have two positives. And the only thing that would give us 10 would be the 1 and 9. The 3 and 3 is not going to work. So we're going to go positive 1, positive 9, and then you are finished. That's really it for factoring simple trinomials. Just want to show you one little extension to this. Now we want to look at an example that at first glance does not look like a simple trinomial. That means that the a value is not equal to 1. It actually is a 2 in this case, but it could be any number. And remember, we have commented all the way along that you should always look for a common factor first. And in fact, this trinomial does have a common factor. So take a second and pull out the common factor, and then see if you can work with the trinomial that's left. And there it is written with the common factor in front and the trinomial that's left inside. And sure enough, that trinomial inside is a simple trinomial. So let's see if we can break it down even a little bit more into two more factors and put our x there and our x there and find two numbers that multiply to 32 and add to 12. There are options 1 and 32, 2 and 16, 4 and 8. And remember to multiply to a positive 32. Both of the numbers would have to be positive or both would have to be negative. Since we have to add to a positive 12, we know that they have to both be positive. So we're looking to do a positive for each of these combinations. So 1 and 32 would give me 33. 2 and 16 would give me 18. A 4 and an 8, both being positive, would give me 12. So that means I'm going to put a 4 in there and an 8 in there. So even though this question at first glance did not look like a simple trinomial, it really allowed us to use our simple trinomial factoring skills once we had already used our common factoring skills. So quite often when it says factor completely or you just are applying your factoring rules, it's important to remember that you always look for a common factor first, and then it makes things a little simpler so that you can do your factoring of your basic trinomial in this question or some of the other basic factoring that you have learned along the way. So this is a good summary of factoring simple trinomials.